results on.
Hi, I'm David Gonzalez, and I'm currently working on methods to provide better thermal support to divers in cold waters at NSWC, Panama City. I've read that astronaut suits require both heating and cooling garments, and my question is, how does an astronaut maintain thermal regulation during a spacewalk in dynamic temperatures? Thank you.
So our spacesuits do such a fantastic job of insulating us from the outside environment that what we really have to do is reject the heat that our bodies generate, because the body heat will not translate through that spacesuit. So we've got a liquid cooling and ventilation garment that allows fluid, water, to travel through the hosing around our body, and then it will pass by an ice pack. Now, me personally, on a spacewalk, I have too many other things to worry about, so I basically sweat in the sunshine and I'm a little chilly in the cold. But I do have the ability to adjust that if I wanted to. It just takes effort, and I'd rather focus on the other things that are occupying my attention.
Hi, my name is Kai Stargel, and I'm from the Air Force Research Laboratory. And my question is, as an astronaut on the space station, part of your job is often as a research scientist. Do you get paired with science projects that align with your background, or are you expected to adapt and learn to maintain new science projects?
Oh, that's a great question. Mark's from the Army, and my background is engineering. So science is something alien to me. But we have great training on the ground. So the instructors and also the researchers will tell us about the experiment and tell us the technique and teach us well. So up here, we will do whatever is on our schedule, and we'll try to help out as many researchers as possible.
Hi, my name is Teresa Keith, and I'm from NOAA. My question is, the global community and U.S. agencies are uniting under the United Nations Ocean Decade by working on the science we need for the ocean we want. How does your work in space help us learn more about our blue planet?
One of the significant things I think about being up in space is the emotional aspect of getting a better understanding of how thin our atmosphere is and how precious this amazing place we live on is. But we have lots of sensors. We've got hyperspectral imagery, multispectral imagery. We've got LiDAR, and all of those things provide us different ways to observe the Earth and gain a better understanding of it.
Hi, my name is Araceli Morales Santos, and I am a resource assistant intern at the U.S. Forest Service. And my question is, I'm fascinated by space and space exploration, so much so that I can spend hours watching PBS Nova episodes about black holes, dark matter, and gravity. What is a particular show, a movie, or a memorable experience that propelled you to a career with NASA?
So for me, when I was a kid, I really liked science fiction movies like Star Trek, Star Wars, and then my dad took me down to Kennedy Space Center. We saw rockets and went down to a Smithsonian Museum. So looking at the real stuff and the science fiction combined, it made me interested to actually go to space, and that's how it started for me.
Hello, I'm Priya Abiram from the Army Educational Outreach Program. My question is, what is the new set of right stuff or character traits that an aspiring astronaut must have in order to reach Mars and beyond? Thank you.
Well, one of the key things about leaving the rest of humanity behind is that you have to get along with the humans that you're traveling with. So I would say the key thing, the right stuff, is really interpersonal skills. You've got to always do your best, but put more effort into making the team of people around you performing their best than you always being better than everybody else. So it's all about the team.
Hi, I'm Ronald Morero, and I'm from NASA. As you observe the Earth on the space station, what weather patterns and landforms are most fascinating to you?
Well, Earth is fascinating. We have a big window called the cupola looking down at Earth, and we have a better quality window as well, looking straight down. And a lot of us, we just spend time in there whenever we have a chance. Um, but for me, the most fascinating thing is actually clouds because it is, it has different forms, different shapes, and during the sunset sunrise time, it you can see the shadow, just a very very long shadow, and it's just fascinating to me. And I take a lot of pictures of it, but I can't remember where I where I took it from.
Hi, my name is Amrita Sahu, and I'm from the U.S. Naval Research Laboratory. My question is, as an astronaut, you probably encounter unforeseen challenges on a regular basis. What advice do you have for aspiring scientists on how to approach a problem that is seemingly unsolvable?
So take my advice with a grain of salt. I am not an expert, but here's my advice for what it's worth. Go ahead and work really, really hard on that problem, and then step away from it and do something fun. Associate with other people that have a wide variety of viewpoints and different approaches to things, and then you'll really get the creativity going, and you might be surprised when a good idea on how to solve that problem you've been working so hard on comes to you.
Hi, my name is Claire Fox, and I'm from the DoD's NSWC Crane Division. My question is, what has been your favorite memory since becoming an astronaut?
That is a tough question because every single day you have a lot of laughs, even here and even on the ground. So that's a very tough question. I think maybe it's tomorrow.
Well done.
My name is Katie, and I'm an intern for the National Oceanic and Atmospheric Association. While working for the Center for Satellite Application and Research, I've been learning about several different satellites in our atmosphere and in space. My question is, how are you able to avoid satellites and prevent collisions with space junk on the space station?
I would answer this question in 3 parts. One, you got to be able to keep track of where things are, and we do have that ability. And then, but it's limited in size. And then you've got to have the ability to move to a new orbit if that new orbit is a better place to be. And then the third thing is you've got to recognize that you can't see everything, so you've got to have a space station that can protect itself. So we've got multi-layers of alloy that help protect us and reduce the impact of an impact on the space station by spreading out that energy. And so far, so good. We haven't had anything hit us that has caused us to start to depressurize.
We want to extend a huge thank you to our speakers and astronauts for being part of today's program. To all the interns watching, thank you for your meaningful contributions you make every day to the federal agencies that you serve. Happy National Intern Day!
Station, this is Houston ACR. Thank you. That concludes our event.
Thank you to all participants.
It's all about the Earth. and what we can learn about it from the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Houston on 2 for velocity calculation station assembly, steps 4, 5, and 4, 6. We're moving on to
Tracy,
step
you
5.
want to go right now for that activity?
Copy, thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Welcome back. This month on Station Life, we're going to highlight the International Space Station as a platform for studying the Earth and take a behind-the-scenes look at what it's like to live and work aboard the International Space Station. You know, they say a picture's worth 1,000 words. The first pictures taken by humans from space forever changed the way we view ourselves and our world. If you've ever flown on an airplane in the window seat, you know the natural desire to stare out the window. Well, aboard the International Space Station, one of our favorite things to do during our off time is to stare at the beauty of our home planet.
Take a moment every day to look out the window and appreciate where you are.
Literally watch the Earth go by. We're going around the Earth once every 90 minutes. So you see a sunrise and a sunset every hour and a half.
It's just so vast and so vibrant in color, and so much contrast between the black that it kind of overwhelms you at first.
Don't just look out the window during the day. Go for the times between day and night, and then night and day, and take some time to look out into the universe at nighttime, because that's when you can really see all the stars. And you can see that the stars are not only like in a planetarium where they're sort of in a 2D field, they're actually 3D, and some are farther than others.
But you could see the blues and the oranges and the reds and the whites and the yellows, and really see more color about the stars, which indicates more about where they are in their life cycle, what kind of things they're burning and doing. And you would think that you'd get tired of looking out the window, but you never do.
Like I said before, a picture's worth 1,000 words. But in the case of International Space Station imagery, a picture could also be worth 1,000 lives. An imaging system aboard the station called Environmental Research and Visualization System, ICERV, captured photographs of Earth from space for use in developing countries affected by natural disasters. This is yet another way the orbiting laboratory is serving humanity off the Earth for the Earth.
SERVIR is a joint NASA and USAID program where we're working with developing countries around the world and strengthening their ability to use satellites to address the many problems that they have, including floods, fires, harmful algal blooms, and other types of events that they have where they can use satellites to really make better decisions.
We're using space information to help decisions that affect people in the village where they live.
When there's a major disaster, governments around the world come together, and they provide all of the satellite data basically that the world has to offer. But there's smaller disasters that occur in the countries that we work in that may not make the front page of the New York Times, but in that country it's a really big deal. We asked ourselves, could we make a difference if we had a dedicated imager for acquiring imagery quickly after natural disasters, and to be able to provide that imagery back to the countries that need them, that have real decisions that need to be made with a very quick turnaround. As NASA, we looked in our own backyard and started thinking, could we use the International Space Station? The International Space Station was really a fantastic asset to take advantage of because it passes over 90% of the Earth's populated area every 24 hours. We developed an imaging system and we called it ICERV, which basically is a camera and a telescope system that sits inside the International Space Station and can collect imagery when it passes over natural disasters or other events that we need to collect imagery.
Initially, we were planning to take a few pictures per day.
So we contacted all the USAID missions around the world, and in total we had more than 2,000 requests coming, for people who need images from ICERV.
And we moved to like 1,000 images per day.
We provided ICERV imagery for many, many natural disasters, including floods and fires, for deforestation, for volcanic eruptions, for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
And now we have a huge archives of images of areas around the world. So this is something that was not really there before.
ICERV is an example of, in essence, making the International Space Station even more international and connecting space to village to better understand and protect our home planet.
Imagine bread loaf-sized satellites zipping around the Earth each day, imaging the globe and providing updates on the environment. Thanks to the International Space Station, this constellation of satellite image gathering has been made a reality. With the mission of photographing the majority of the Earth every day, Planet Labs created small satellites, individually referred to as doves, to capture ground imagery for use in humanitarian, environmental, and commercial applications. With the 2005 NASA Authorization Act designating the U.S. segment of the station as a national laboratory, the space station drives growth of a robust commercial marketplace in space through endeavors like Planet Labs. The Earth imaging mission of Planet Labs' Dove satellites takes another leap toward creating benefits on Earth, resulting from innovation in space.
What happens if you wake up in the morning and you understand the state of the world as it is right now?
What could that data enable? How could people make smarter decisions? How could, for example, a farmer get better yield on his or her crops? How could somebody help disaster response? How can we use satellites to help humanity? That, in many ways, was the underlying thesis of doing Planet Labs, was to get data into the hands of people that could enable us to make smarter responses to that.
Planet Labs set out with the mission to photograph the entire Earth every day. And they thought, how are we going to do this? They said, let's build our own satellite.
Commercial imaging satellites, they're very large. They are very expensive. We took a different approach.
By making them really small, we can launch lots of them, and by launching lots of them, we can cover this, to get to this mission of imaging the whole Earth every day.
If we can do that, then we can literally change the way that we see the world.
And they called it the Dove. It's about the size of a loaf of bread.
Our doves are basically mainly a big camera with a telescope looking down to take pictures of the Earth. We initially developed the first Dove satellite in our garage. So we kept on iterating the Dove design, we made it better and better, and eventually we put our first one into space. We had no idea what the quality would be like.
I mean, we didn't know if it was going to work.
But we got an image down and it was so beautiful that we knew at that point we could make this technology work.
Wow, we can really do this.